Imagine two different factories. They each just signed the purchase order for the exact same $1 million sheet-fed digital press. Now, look at this chart comparing their performance after 6 months. Factory A is pushing out double the volume of Factory B while logging half the downtime. The hardware is identical, right down to the firmware version. When a production run suddenly grinds to a halt, an operator's first instinct is to point at the hardware. They assume the machine failed. But the vast majority of production losses originate in the logistics feeding the press. Substrate pallets staged out of reach, critical operating details lost during a chaotic shift handoff, ambient room temperatures drifting wildly out of spec. An industrial press operates as a regulated system, relying entirely on stable inputs to produce stable outputs. Control the environment around the machine, and the machine stabilizes itself. This flowchart illustrates the AMEN. Protocol: analyze, model, execute, normalize. It is a strict operational sequence designed to take a system throwing errors and force it back to a known good baseline. Under tight deadlines, operators routinely skip the work of analyzing the failure mode or modeling the root cause. They jump straight to executing a quick fix, turning dials to see what works. That creates motion, but zero actual progress. Without taking that final step to normalize the system, installing a specific check, control, or procedure to prevent the exact same error, the problem is only suppressed until next week. The discipline to maintain that baseline starts the minute an operator walks in the door. The first 60 minutes of the day are dedicated exclusively to bringing the system from a cold state up to a validated ready state. Wiping down charge rollers and replacing impression sheets serve as the validation steps that make the rest of the day's production time trustworthy. Skipping that morning routine borrows 30 minutes against a future mid-run failure, paying them back at 4 times the interest rate. Once the hardware is validated, the focus shifts to the workload. The operational rule here is absolute. The press must never sit idle waiting for a human to make a decision. Operators construct a continuous queue. Ahead of the active press sits a 60-minute buffer of ready-to-print work. Inside this buffer, identical substrates are grouped together. Because switching from a glossy to a matte finish incurs a setup cost, contiguous sequencing eliminates unnecessary physical changeovers. With 60 minutes of solid production locked in, this buffer becomes a shock absorber. The operator is free to handle secondary tasks, like staging tomorrow's paper or inspecting output, without ever starving the press of its next job. The queue acts as a structural firewall. If the buffer runs dry and the operator's lack of planning is the reason the press goes idle, the entire system fails. Keeping the press fed leads to the longest phase of the day, active production. The difficulty here lies in a pace mismatch. The machine is executing one steady task, while the human is managing 5 overlapping logistical streams at once. If a minor quality issue arises, but the output remains commercially acceptable, focus on containment. You sustain the run, hit your targets, and save the heavy optimization for a dedicated downtime window. Stopping mid-run to make unmodeled adjustments introduces variables you can no longer cleanly track. Tweaking color settings by eye without localizing the source of the drift is quite literally gambling against the machine. As the active run winds down, all remaining focus funnels into the final 30 minutes of the day. This is the shift handshake between the incoming and outgoing operators. This handshake functions as a binding informational contract. It transfers the exact state of the system, the depth of the queue, and any active bypasses to the next operator. If a warning light triggered at 2 p.m. and the outgoing operator omits that detail, that missing information becomes a literal defect injected directly into the next operator's shift. Over time, a poorly managed operating system accumulates friction. Every ignored notification, every bypassed sensor, and every skipped maintenance task creates a specific operational debt. And that debt always has a deadline. This graph charts the damage of debt over time. The exchange rate compounds. Skipping a 5-minute daily wipe-down rapidly degrades components, elevating a minor chore into a weekly issue. Let that slide, and it guarantees a line-down event, requiring multi-day service to replace ruined parts. Production excellence relies on engineering predictability into the hours leading up to the run. It is the result of rigorous discipline, not reacting to alarms. Identical hardware will always produce different economics based on the human structure wrapped around it. Analyze, model, execute, normalize. Repeat with intent.